والسلام على من عباد الله اصطفى خصوصا على عبده محمد وعلى اله وسلم. We make dua for Allah to bless us in whatever we do, okay? Allah gave us again ability. I always thank Allah for this. Another day to live, another opportunity, okay? To say more subhanallah, more alhamdulillah, whatever, to pray more. So we always thank Allah for that. Okay? Our topic today is periodic table. We have looked at periodic table before, but we look at it superficially. Now we want to look at it in a greater detail than we did before, because it's a very famous area. Whatever they put in this syllabus is what they are going to examine you on. So we have to look at it in detail. Now the periodic table we saw before, so arrangement of the elements in kind of a table, in kind of an order. Okay? This order shows them arranged in a table form from group 1 to group 7 and then group 0. Okay? We say group 1 are metals, and then up to group 2, 3, okay, we got transitional metals. Then you go to group 4, which is carbon. Then you go to group 5, which is group 5, the first one is 1. Group 5, the first one is nitrogen, okay, which is 5. And then you go to group 6, which starts with, I think, oxygen or fluorine, okay? Then you have group 7, okay, fluorine, yeah? We have group 7, which is fluorine and chloride. But group 6 is oxygen, isn't it? Yeah, that's right. Now we want to look at first of all, the history of the periodic table. The history, okay? Two names, okay? John Newman, okay? Two names. John Newman, 1860. Okay, and Dmitry Mendeleev. My teacher said as Mendeleev. You can say Mendeleev. And before that one, before all of them, okay, before all of them. So, by that time, basically only 30 elements were known. 30 elements. By this time, it has gone up to 35 elements. And his time, up to 59, I think. 55 out of 59 elements. I think, I'm not very sure with that, okay? So, before, just now, we saw the periodic group like this. Can you remember? Okay? Then you have 1 and 2, then 3 and 4, and 5. You have 6, 7, 8.
Yes, 57 elements.
57 elements, okay? 57 elements. 57 elements. Okay, now here, group 1, we know it starts with lithium, then sodium, then potassium in it. Okay. Then group 2, we have beryllium, magnesium, and calcium, copper in it.
No.
Or copper is down. Okay.
No, copper's not there.
Okay. Basically, here we have nitrogen, here we have oxygen, you have fluorine, chlorine, here we have helium, and what?
Xenon.
Oxygen, sulfur,
Helium, neon.
phosphorus. Okay? Okay. Now, we're going to look at these things closely. Now, before John Norman come to the scene in 1860, basically only 30 elements are discovered. And there was no particular arrangement to signify the characteristics of the elements, how they relate to each other. Okay? But John Newman came, he realized that the atoms, if you arrange them in terms of the elements, okay, if you arrange them in terms of atomic mass number, okay, which is the number of protons from the number of neutrons, the mass of protons from neutrons is called the mass number, you will discover some kind of a cycle. After 8 element, from one element to the 8th one, he can see similar characteristics, okay? Now, from lithium, which is 2, 1, okay? Now, after eight elements, you count after 8 elements, he realized that there's sodium, which is 2, 8, 1, okay? But he didn't know at that time electrons and protons were not discovered. Do you understand? But this one, 2, 8, 8, 1, he didn't discover it like this. I'm demonstrating to you what he realized at early age. That if you count the element, 1, 2, 3, 4, 5, 6, the 8th one will come around again. Okay, there will be 8 electrons and 1. He didn't discover electrons, protons, or neutrons, but he realized that this and this, lithium and sodium, have similar characteristics. Okay, so he based it on atomic mass. So in the exam, he based it on atomic mass. He said there must be a relationship between the atomic masses. Okay, so another 8, when you count another electrons, 8 elements, he'll come back and say 8, 8, 8, 1, and he realized that they have similar characteristics. So that means if later we knew in the modern periodic table, we knew that they all have 1 electron in the outermost shell. So therefore, they will have similar chemical and physical characteristics. But he didn't know at that time. Okay? So these people are very, very, very intelligent man. John Newman was a British guy. Newman is Newman. He's a British guy. Now came in 1860 or 1869. Okay? This Russian guy. Okay? He's a Russian guy. He's a Russian. Even the name can tell you that he's a Russian, isn't it? Okay? The Russian guy came. By that time, about 57 elements have been discovered. He says, look, I don't think it is atomos mark that determine how these things will be arranged. We should look at their characteristics. Those with similar characteristics are arranged. You understand? In that group. Okay? He saw his own crude way of arranging the element, but precisely he was called the father of the periodic table. Okay? The father of the periodic table. This Russian guy. Because what we have today for the periodic table principally come from this guy, Mendeleev. Okay? He discovers that if you look at him, they have similar characteristics. Okay? He put lithium, sodium, potassium, wonderfully in group 1. Group 2, he put beryllium, magnesium, and calcium. And each of them, he realized that within the same group, they have the same type of reaction. Okay? The same he realized in the non-metals. Okay? Because from here to here, although not they are all called non-metals, they are called metals. Okay? Why metals? Because when they react, they donate electrons. Yes? Okay. So he called that first one group 1, second one group 2, then group 3, where is it boron and aluminium?
Yeah.
Yeah, boron and aluminium. And group 4 we have carbon. And silicon, yes. This is group 5 we have
Nitrogen and phosphorus.
Nitrogen and phosphorus, yes. Phosphorus only P in it. Yeah. And group 6 we have
oxygen and sulfur.
Oxygen and sulfur, yes. Okay. And group 7 we have
fluorine and chlorine.
Chlorine and iodine in.
Chlorine
yes.
Iodine.
And group 8 we have helium and neon.
And argon.
And argon, okay? Neon and argon. Neon and argon. Ne.
Ne and Ar.
Ne, yes, and argon, Ar. Okay? Now, and he realized that the group 8 ones, they're not very active. Why? Because at that time they didn't know about protons and electrons, but they all have 2 electrons in their outermost shell. They have the complete number of electrons in their outermost shell. This is the K cell. It can take only 2 electrons. So it will not need another electron, so it cannot react. Neon, it cannot react because to react, you either have to donate electrons or share electrons. If you share electron, it will be 16 in the outermost shell, and that cannot go. Okay? So that's why they are very unreactive. They are called noble gases. We are going to, some people call them group O. Okay? So you can see all of these, at least for the first two, they are all gases. Okay? But as you go down, they become heavy gases and turn into solids. Okay? Now that's what I'm going to look at it. But you have to go and study this. You know, I cannot exhaustively within 30 minutes give you all the history. Okay? You have to read about that. Now what we are after, this is the history of Mendeleev. He was commended for one brilliance. He says, now if we discover another element, we can safely say it has a position here. Okay? Let's say we discover an element. Okay? That element is called X. We don't know. But when it reacts with water, it reacts similar way as group 1 element. You see? Okay? It is brittle, it's silvery in color. Okay? When it reacts with water, it gives us hydrogen. Okay? When it reacts with oxygen, it produces metal oxide. Okay? So, he can safely say that this element probably lies in group 1. Now, if you look at the structure of it, you realize that it's 28881. It has one electron in the outermost shell. Then it is group 1. Do you see? Okay. Now, rubidium.
No, cesium.
Cesium. Cesium is one of the metals used in nuclear physics, isn't it?
Yeah, medium.
Yeah, they call radioactive. Eh? Yeah, it's radioactive. Very explosive when you mix it with water. Now, first of all, group 1. Group 1. Now, group 1, they are, just write it down, they are lithium, sodium, potassium. Okay? Potassium. Potassium is K, and they are 2,1,2,8,8,1. Now we can see they are called group 1 because they all have one electron in the outermost shell. And they are called alkali metals. Okay? Alkali metals. Because when they react with water, or when they react with oxygen, they form what we call alkalis. When they dissolve in water, when those react with oxygen, they form what?
Metal oxide.
Metal oxide. Okay? If the metal oxide dissolves in water, is called a base. And this is very, very important because we are going to do, when we do acid and bases, then we will know exactly what a base is. A base is an alkali that can dissolve in water. If it doesn't dissolve in water, it's not an alkali. Okay? If it doesn't dissolve in water, then it's not an alkali. Okay? So basically we can say an alkali is a metal oxide that can dissolve in water. An alkali is a metal oxide or metal hydroxide that can dissolve in water. So when an alkali dissolves in water, it's called a base. When a base reacts with an acid, okay, it uses salt and water. Salt plus water. Okay? So they are called alkali because metals, because they can donate electrons, yes? When they react, they donate 1 electrons in the outermost shell. Okay? When they donate one electron, they form an ion, yes? Like sodium, donate 1 electron, it becomes a sodium ion, sodium plus. So is potassium, reduce 1 electron, it becomes potassium plus. Okay? So all of them, their ions are 1 plus. So therefore, when they react with group 7 metal, they formed, number 1, they formed ionic compounds. Okay? Ionic compounds. Okay? Do you see that? They react. They are called alkali metals. When they act with oxygen, they form metal oxide. When that metal oxide dissolves in water, it's called a base. And when a base reacts with an acid, it forms salt and water. Okay? That is the first information we have about it. Now let's look at the physical characteristics. Whenever you talk about physical characteristics, you talk about appearance. Okay, how does it appear? How does it feel? Whether it's soft or hard. Okay? Hard, okay? And that's called the texture. What is the texture? Okay? 2, boiling point, isn't it? Boiling point. 3, melting point, isn't it?
Yeah.
Because these things are metals, in it, and they are solids, in it. Yes. So the appearance. So we can say the state of matter. Their state. Either they are solid,
Or liquid or gas.
liquid. We are going to do that state of matter, and gas. The physical characteristics. Okay. And there's something called density. Okay. They are density. So these are called physical characteristics. Physical characteristics. Physical characteristics. So when they ask you to describe group 1 metals, you're going to describe it in form of their appearance. Okay, look here. Okay, they are soft, silvery. Okay, so I already put how they feel, soft and silvery. Yes, how they appear, they are gray,
Silver.
silvery and gray in it, or gray. Okay, how they feel, soft, hard. Okay, they are soft. Some are soft, some are hard. Okay, you can cut them. Okay, you can cut with knife. Yes, cut with knife. These are important. For you to know these things. You can cut them with knife. Now, boiling point, they have high boiling point. Most of them are 500 above centigrade. Yes, we can look at the boiling point. I think there's I saw in the one paper, they put the boiling points. Hold on. Okay. Yes, the boiling points. Okay. Lithium.
That magnesium melts at 2000.
Hold on. Density. Okay. When you put like this, density, melting point, and boiling point. What is melting point and boiling point?
The melting point
Is the temperature at which it melts. If it's a solid, yes? Boiling point, it's a point it boils, yes? Okay.
that sodium is 98.
Hold on. Okay. First of all, density is how strong they are. Like aluminium has a high density. That's why it's used for building it. Yes, but this thing they can be used for building because they have low density. Now sodium, I'm not going to put the name. I'm going to put the names on the rubidium. Okay. Cesium, I don't want to put there. But look at the density. It's very weak. 0.53. Okay. 0.97. 0.86. That's a break in the 1.53. Melting point 181 Celsius, 98 Celsius, 63 Celsius, and 39 Celsius. Okay, look at the boiling point. 1342, 883, 760, 686. Okay, look at it. What do you see? What characteristics do you see? These are physical characteristics. What do you see? That as you go down, the density of them increases. Why would that be? Why would that happen? Can you relate that to what you know about them?
Because there's more electrons.
More? This is 2, 1, 2, 8, 1, 2, 8, 8, 1, 2, 8, 8, 8, 1.
The increase of electrons.
The atoms are increasing, isn't it? The size of the atoms are increasing, okay? They become bigger. So become bigger, more tensile strength. They call tensile strength. Ability to bend, innit? Yeah, more tensile. Because as it becomes bigger, the tensile strength, called the density, increases, innit? Now look at the melting point. Look at the melting point. So as you go down, the density increases. But as you go down, the boiling point decreases, isn't it? Yeah. The melting point, the boiling point also decreases. Why? What do you think? Why?
There's also a characteristic.
It must relate to the nature of the atom itself. Okay, so there's something. Let me explain that one. Maybe. Now, let's look at them. You can't do this. Look at lithium. No, making it should be bigger than it should be. Lithium, okay? 2, 1. Sodium. 2, 8. Okay, potassium. 2, 8. 8. 8. 1. Okay, what do you notice? Sodium, potassium. The size increases, yes? How many protons do we have here? How many protons?
3.
Why?
Because the amount of electrons.
Not say amount. You should use the right chemical word, yes? The number of electrons is equal to the number of protons. So protons will be 3. So basically, proton is positive, yes? Plus 3, minus 3, innit? That's equal to 0, innit? Now look at this one. How many protons do you think? Number of electrons is 11. 11, yes? So 11 plus 11 minus 11. Why am I putting plus and minus? You know?
Because the electron's charge is plus, the proton's charge is a minus.
Because protons are positively charged and there are 11 of them. Electrons are negatively charged and there are 11 of them. So the charge will be 0. Now look at potassium.
Yes.
Potassium is 2, 8,
19.
19, yes? So 19 plus 19 minus, okay? 0. Okay? Now, there will be 19 protons here. Okay? Now, you see, if the protons are positive, they're attracting the negative charges to make this stable. What will you think will be the pull, the electrostatic pull of the last electron in each of them? The pull of the proton on this one electron in this K cell will be stronger, isn't it? So, for you to make lithium to give out this, you need more energy, isn't it? That's why you have higher boiling point. You see? Can you read it now? Okay. This one, you have 10 electrons in atom side. 11 electrons is pulling them. Since there is one extra shell, the pull of these 11 protons on this one electron in the outermost shell will be less stronger, isn't it? Yes. Less stronger than that one. You can see the boiling point is how many? Nearly 500 degrees lower, isn't it? Okay. Now look at that one. Even weaker. Potassium even weaker. Therefore, lower boiling point by even 100. Now, we let this to the chemical characteristics. Now we have finished physical characteristics. Okay, we have seen how they feel. Taste, we have not talked about taste because no one is going to put this in your mouth. Okay, we don't forget about taste. Because some chemicals, you need to know the taste, how they taste. Okay, now we are going to relate this to the chemical characteristics, yes? The chemical characteristics, yeah? Chemical reactions. Chemical reactions. These are called the chemical characteristics, okay? Now, first of all, they react with group 7 metals, yes? React with group 7 maybe I should put that in a different ink. Okay. Group 7 non-metals in it. Non-metals or to form what? Ionic compounds. Yes. Ionic compounds which are soluble in water. Water is the universal. What do you call water? The universal
Force. Solvent.
Yeah. Okay. Okay. Now look at that. So look at it. Sodium, example, sodium plus chlorine. I always use chlorine. Chlorine group 1. Why is chlorine C2?
Because
Because chlorine is
change of valencies.
Chlorine is a gas.
The gas, yeah.
All you have C2 are gases. Okay? Gases. C2 because they form a what bond?
Covalent.
Covalent bond. Chlorine, covalent bond in it. Yeah. So chlorine, that will give you sodium chloride.
Yeah.
Okay? Now we balance it. We do our balancing.
Yeah.
This is 2, 1 here, 1 here. Correct.
Yeah.
2 here, 1 here. So we make this 2.
Yeah.
When we make that 2, that sodium is 2 here, sodium is 1 here. So we make it, it's called the law of conservation. You'll do that later when we do some topics in chemistry. Now, see, they form metal chloride, which are ionic compound, and ionic compounds are soluble in water. Okay? Ionic compounds. So ionic compound. And ionic compounds are soluble in water. So therefore, if you have a metal called X, that X that X reacts with chlorine, and you have X chloride, I don't know how it will be. Probably going to be that. Okay? Okay? Meaning, I put 3 here, meaning this, the valency of this one is what?
Where?
X. What is the valency of X?
XCl3 2. X.
Look at the compound. Look, yeah. XCl. What will be the ion of X?
3.
Why?
Because exchange valencies.
Exchange valencies, yes. Because what will be the valency of chlorine? 1, because that's right. Exchange valencies. X react with chlorine. This comes here, that comes here, innit? Yeah. It becomes Cl3 and X only 1. I've been saying this for a long time. You have to recognize these things, yes? So if it is like that, automatically you can say that this element is in group 3. Because when it reacts with chlorine, you need 3 of chlorine, which is 1 minus. You need 3 of chlorine to react with X. So X must be 3 plus. You understand? If this happens and it doesn't dissolve in water, you can tell it's not a group 1 element. We know chlorine, but we don't know X. Okay? We don't know X. But by the characteristics of its compound it forms, we can predict that this element is not in group 1. Because all group 1 elements, when they react with group 7 element, they form ionic compound, and that ionic compound will dissolve in water. So if XCl3 does not dissolve in water, we can say it is not from group 1. Because all group 1 element are alkali element. When they react with group 7 element, they form ionic compound which dissolve in water. You see it? That is the first chemical characteristics. Okay? Now, the most impressive one is reaction with water. Okay? The most impressive one is the reaction with water. Yes. Vigorosity, yes? So, number 2, when they react with water, okay, they the reaction, vigorous. Okay, the word here is vigorous. Okay, vigorous, yes. And they form metal, because they are metallic. All group 1 are metals in it. Metal hydroxide in it. Hydroxide and water. And no, when they react with water, how can it produce water? Okay, hydrogen. So we should have said this one. Our number 2 is reaction with water in it. Our number 2 is, our number 2 chemical characteristic is reaction with water. Reaction with water. Okay? So, let's say potassium, I'm going to explain what happened. Plus water will produce potassium. This is called the word. This is called word. What is this called? This is called what? Word equation. And hydrogen. So, don't know. Okay? They produce potassium and water. And the equation is potassium plus H2O will produce potassium hydroxide plus hydrogen. Now, is this balanced? Does it balance? No, it doesn't balance. 2 hydrogen, 1 oxygen, 3 hydrogen in it. Yes, 3 hydrogen. So what do?
You have to add.
You put 2 here and 2 here. It's balanced now. Yes. Now,
No,
it's not balanced.
No, you have to add 2 for the hydrogen as well.
Yeah, hydrogen and 2 here. No. Okay.
Because only 4.
Only 4. Yes, it's now balanced. Yes. Now, lithium, when it reacts with water, it makes a lot of pop, pop, pop sound. But sodium, when it acts, is very vigorous. Okay, bam. Now this potassium, when it reacts with water, is even explosive. Yes, the container will blow. But guess what? Cesium or rubidium. Okay, cesium, is Ce, or rubidium. Those ones are explosive. If you take potassium in water and throw it in water, it will bam, boom. But this one, huge explosion. Okay, huge explosion. The reason is same thing. This one, for it to let go, the one electron in the outermost cell, there's stronger electrostatic forces attracting this. Okay, this one, the electrostatic forces is lesser because there are 2 cells around the positive protons. Yes, they are in the nucleus. They attract these electrons to make them stable. Okay, you can see them form by themselves in the solid form. Okay, now why this one is most even explosive reaction? Because the forces that is attracted the last electron here is much weaker, so it can easily go away. That's why the boiling point was lower. You can easily let it go. That's why immediately you put this in water, it explodes. Because immediately, the electron in the latter atmosphere can react with hydroxide in here. Because remember, H2O is hydroxide ion plus a hydrogen ion in it. Yes. A hydrogen ion plus a hydrogen ion in it. So it reacts with the hydroxide ion because it's K plus, react with the hydroxide ion. That's why you have potassium hydroxide. And this is very important compound in the lab. Okay? They call it what? How do you call sodium hydroxide? It's used to test some other compounds in the lab. You forget. It's the catalyst. Indicator. See it. Okay. Now, we have seen the reaction with water. Vigorous, more vigorous, explosive, even dynamite. Okay? Depending on the electrostatic forces, the number of cells around the nucleus. Okay? That's in the exam, that's what they want you to say. Okay? That's what they want you to say. 45 minutes. I'll tell this and then I don't like it. Maybe we have to cut it into different segments. Okay? Now, number 3 is reaction with oxygen. Reaction with oxygen. So, when they do so, when they boil, when they add oxygen, we call them redox reaction, okay? Reduction and oxidation, yes? Reduction, we are going to do this topic, okay? Reduction and oxidation, okay? Oxidation means adding oxygen, yes? Adding oxygen in it, okay? Or donating electron in it, okay? Reaction means taking out oxygen. Reduction means taking out oxygen or subtracting electrons, okay? Now we do oxidation. It become oxidized. The metals become oxidized, yes? The metals, or alkali metal, sorry, we should write the word. The alkali metal in group 1 become oxidized, okay? Become oxidized, forming what? A metal oxide. Okay, which when soluble in water, what do you mean by soluble? In water, forms a metal hydroxide. We are back to our metal hydroxide. Okay? So if a metal hydroxide is dissolved in water, when it dissolves in water, it's called what? It's called a base. Okay? It's called a base. You can dissolve in water. And this is basically, and the reaction look like this. Okay? Sorry, I have to clean that. Potassium plus oxygen will give you potassium oxide in it. Where would I put numbers?
On front of both cases.
Huh?
On front of both cases. On both potassium.
On both potassium?
Yes. In front.
Here, that's on 3, innit? So you look at it. Alkali metal become oxidized, forming a metal oxide, which when soluble in water, form a metal hydroxide. Okay? If the metal hydroxide is soluble in water, then it's called a base. And when a base react, there's a third one I want to. Okay. Number 3. Yes? Reaction with acids. With acids. Yes? What happens? What happens when they act with acids?
It releases hydrogen.
Releases hydrogen. Releases hydrogen. And they form metal. Metal halide.
Or halogens.
Yes. Halides. When they react with, they call halides, okay? Not halogen, halide. That is in the group of fluorine and chlorine, in it. So like potassium will form potassium fluoride and potassium chloride. Okay? And they form salt, yes? And this, sorry, they form a salt. They can form a salt, yes? They can form salts. Form salt. An example is potassium plus hydrochloric acid will give you potassium chloride plus hydrogen. Is it balanced? Check it out.
No, it's not.
It's not balanced. What do we do?
Add 2 in front of the HCl.
We put 2 here.
Yeah, 2 there.
2 here,
Yeah,
and 2 here.
Yeah.
Yes, that's right. So when they react with acid, they form an ionic compound, which is a salt, and they form hydrogen. So if you want to manufacture hydrogen when in the lab, that is the reaction you do. Okay? Now, that's clear, yeah? So you have to know these things. You have to know these things about the first group. The group. Group 1, they are reacting with water. They are reacting with